Hey everybody, got I think on the screen you've got on your far left you've got Dave Rozier, who is one of our hosts for our Controlled Environment Agriculture session, and next to him you have Gustavo, who is in Colombia, and he is joining us as a guest tonight. And next to him you have Peter Cordell. And Peter, you're in the DC area, or are you located right now? Where are you physically today?
I'm in Minneapolis. I'm a partner with Dave in his.
That's what I thought. But and you're coming. You're making a trip to DC. Yeah. I know in the near future. Okay. Yeah, so Peter's in Minneapolis, and as Dave in the Minneapolis-St. Paul area, and then obviously you guys know Jerry, and there's me. And I'm actually on the phone today because with all of us on here, it really takes up bandwidth, and I would be. My satellite system and such would take up too much bandwidth. This is going to be fun, you guys. You're going to get a treat tonight because we've been having for about the last half hour a really great discussion about nanobubble technology and about us as business people. And I shared this with several of you that were already on a little bit early. This was an introductory call for the five of us. We didn't all know each other, and we intended it to be private, and I accidentally, I think, or somebody, we hit the start broadcast, and so then all of a sudden it was available for all of you too. So we didn't really end up talking about the business things we're going to privately, separately, but I think it's a great example for all of you, and mainly this is the people who are going to watch this on a replay, is that the way the whole economic action process should work. We have got to be collaborative, everybody. We have got to create business relationships in Colombia and in Japan. You'll hear Jerry talk about that. And with Minneapolis. So we've got Northern Colorado, Minneapolis, Washington, D.C., Columbia, and all of you. And I know some of the names out there. I know Robert's from down in the Texas area. I know Richard's also in the D.C. area and a variety of areas. And I don't know where the locations of some of the rest of you are at, but that's what we got to do. We got to collaborate. So I'm going to turn it over to Dave here, Dave and Jerry. I'm going to actually turn my webcam off, and then as we go a little bit later, Peter and Gustavo are going to weigh in. Gustavo is a nanobubble expert, everybody. This is such a pleasure for us to have him here with us tonight. He has been working with nanobubbles, and Jerry will introduce, I'm sure, and Gustavo will talk to us about it. So this is special. So I'm going to shut up here. I'm going to turn it over to Joe. Before I go there, Mark, thank you. Mark B. behind the glass. He is here every time. This is our, Mark, what session is this? 262 or something? And he's been on every one. And this is, I think, our 8th hour or 9th hour. We still have one more session this week. I want one announcement. If you can do it on Saturday, come. It's 11:30 Mountain. You've got to translate it into your time, whatever that is, and watch an amazing presentation from a group in Russia who are turning a 20,000, looks like we lost Gustavo there from his camera at least, they're turning a 20,000 hectare space into something back to the Pleistocene zone. And they're already seeing carbon sequestration, and on a micro scale, they're seeing climate change. And they're going to come, I don't know that they've ever presented in the United States before. This is going to be really special tomorrow. So we are having a special session here tonight. We're going to have another one tomorrow with some Russian scientists and farmers and ranchers. So with that, Dave, take it away, my friend.
Okay, thanks, Wayne. So we've had a couple questions that some of the people that were listening in ahead of time here, and there's a question for you, Jerry. It said, how do you have a benchmark for the number of gallons for an aquaponic tank per nanobubble machine? It's difficult to evaluate the technology without knowing more about how many machines somebody needs. So I think I'll just let you have that question, but would you want to answer that when it's with your slides? Then that might make more sense. But just so we don't forget that's out there.
Yeah. Let Gustavo answer that, because you know, volume and you know, there's a number of factors: the dissolved oxygen level, total suspended solids, all that stuff. Gustavo, go ahead.
Okay. Good night, everyone. Those are pretty good questions, both. Nanobubble machine, we have several sizes for every system. When we're talking about a big system, of course, we have more water, so we need to see how much oxygen or air do we need for the plants we're going to grow. I mean, it all depends on the size of the crops. It would all depend on the size of the volume of the water that we're going to have going around the system, and also the fish. I mean, it's not the same to give oxygen for trout and it's for tilapia. I mean, tilapia needs very, very little oxygen in comparison with trout. Maybe the jade perch it's another fish that needs very good conditions of oxygen. So it would all depend on the size of the system and on the species we're growing and the vegetables we're going to have in the hydroponic system. So
so there's a number of dependent variables, and there's a formula that you can use to come up with a calculation.
Yes, of course. I mean, I repeat, it's not the same to have trout or having trout with basil and then tilapia with basil. It is not the same. Or lettuce. It's a different species to grow. So it would all depend on finally on what we're going to do or we're going to grow.
Okay. That's certainly, you know, without having specifics, that's as good an answer I think as we can give. Dave?
Yeah, and I'll just add, you know, certainly depending on the species of the fish, you know, Peter can attest that we had, what, 20,000 rainbow trout we liquidated when the Lenten season. Anyway, they need a lot of oxygen, but, you know, it's a complicated equation, as in you've got the biomass of the fish, you've got the DO level that they need, you've got the temperature of the water, that plays a big you know, part on the DO or dissolved oxygen, barometric pressure, how deep the tanks are. There's quite a bit of things that are into that. So it does take somebody to calculate that all out for you. So I think, you know, you bring a pretty good question, but I think what it has to have is maybe Gustavo has a detailed questionnaire on some of that that what might work. If there is such a questionnaire, maybe that could be posted on another, you know, on the website at a later time here.
Absolutely.
And then also today, I think one of the participants in the audience here today, Richard, sent an email to I think Wayne and Jerry and I, looking for some more information. It looks like I think Richard's putting together a 3P on the East Coast, and he was looking for some information, and I'll say Peter knows all of this information very well too. We actually had put together, it's a very long process, but I'll just say it's a program called the EB5. Is for foreign investors and in the United States to gain access, and it's quite an exhaustive, you know, lengthy document of things to put together, and a lot of it is how many jobs are going to create, what's the local economic, you know, impact, what's the you know, the national impact, and a lot of that, and we've put those together as far as our farms before, and so, you know, we can you know, we sit down and get that information that you have and say, okay, here's how many jobs it would create for a farm system that say is 40,000 square feet, and then we can extrapolate that into and help you as you're putting your 3P together. So you know, we're certainly there as a resource. So. And so I think what we'll do is we can answer that email offline later. So let me just I'm going to kind of go through the slide deck here, and again, I'm Dave Roser, founder of Garden Fresh Farms, and Jerry, you've already introduced yourself, but
yep.
And Wayne last week made a little fun about calling it Ben and Jerry's. So you know, we're not Ben and Jerry's, so we don't grow ice cream. So
I do eat it though. I tell you that.
The other is I just wanted to bring it up. I had put this video on 2 weeks ago, and I think I had this on as a follow-up. I think it's a very important video on the tomato. Why tomatoes are tasteless in your grocery store today. And you know, for those of you who like a little bit of science, I think you'll find it interesting because it came from a laboratory chemistry type of environment as opposed to an agriculture environment. So they're giving you the chemical reason why that tomatoes have been genetically modified into something that ships well and has a specific color that a bunch of people picked as the color of a tomato and not necessarily what was a natural color for a tomato. And so the reason I think not only is it interesting as to why all of this happens, but I think it makes a very big, very strong case for local, and why when you're buying local, what does that really mean? Not only you want to be creating jobs in your own local environment, which has an impact on the consumer as well, but really when you're coming down to produce, the impact that you can have by buying local is really really heavily weighted on the consumer, and you always want to please your customers as much as you can. So you've got a product that tastes better, that is more nutritious for you, and is going to last you know, in your refrigerator longer. You know, so you have less spoilage, less cost. So yes, there's the economic advantages which everybody benefits from, but buying local, especially in the fresh produce area, is a huge benefit for the consumer.
And Dave, that's an argument for our concept of distributed production. In other,
yes.
Rather than having centralized systems and shipping the same food all over the country, you can then account for local tastes. You can account for local growing species. And that the large retailers, the large wholesalers, the large growers can't do that. Anyway, just comment.
That's right, and they're taking a lot of heat for it. Plus, the amount of spoilage in a grocery store is huge. So, you know, if you back that up and say, you know, if you've got 25% spoilage in a grocery store in the produce area, well, that means you just planted 25% more land than you actually needed to. You actually drove a tractor 25% more than you needed to. You know, you start rolling that up, and what that does, you know, for the environment and actually driving the cost up on your food. So
absolutely. Moving along.
All right, so let's move on. We were talking last week, and I'm going to go through these slides quickly here, but talking about design, talking about reality, talking about investment opportunities. And so, you know, this is one of the thoughts of the mobile design. Actually, we're going to be building the brand new one. Just had a meeting here this week on the final designs for our orbiting garden in a shipping container, and we're going to be building that and actually sending that out to Colorado very shortly. So we're really looking forward to that. Solves a lot of problems in a lot of different areas that we can be in. So so that was just one of the designs. You know, we're also here's a existing building, just how we can rehab a building and bring some life to a building and improve the real estate values of the building as well. So this is a project that's moving forward here. So and then last week we were talking about which comes first, the chicken or the egg, the investor or the farmer, and you know, just our discussion about you know, small farms, and you've just got so much infrastructure and overhead to overcome. So it really needs to be a bigger farm. Before World War II, a 40-acre farm was viable. Today, a 200-acre farm is small. So the economics have changed, and you really have to have the scale to survive here. So, and jump in at any time you want. Jerry or Peter.
Yeah, I mean that's absolutely true, and it's just as true in aquaponics and in hydroponics as it is anywhere else. The value, of course, we know, is that in urban centers, real estate, square footage real estate is at a premium, and so the ability to grow vertically multiplies the amount of if you're expanding vertically, then you're not expanding horizontally. So you're using cubic feet instead of square feet, and that changes the equation, right, Dave? I mean, we can grow an awful lot in 1 acre. We can grow 10 or 15 acres if we expand it horizontally. So there's
right. Our metric is in a 1 acre building we can grow as much as in 100 acres because we're all year round and we're stacked high. Now you add that to the as we say, Garden Fresh Farms being distribution game changer, that now what you do is you put that farm next to a distribution center, and let's just use the East Coast, for example, because of the density there of consumers. But the one farm that we're working towards building in the Connecticut area, actually there's 30 million people within 100 miles of that particular building. So I don't know, no matter how you want to cut local, you got 30 million people within a 100-mile radius.
Yeah, the USDA figures that I think it's 250 miles is considered local food. You can call it local food legally.
Right, and Walmart looks at it if it's the same state. One of the grocery chains, Hy-Vee, looks at it if it's 200 miles from the distribution center. So, but it may go 200 miles to the distribution center and 200 miles back out. So it's being able to change where you grow things. It's just a huge benefit. To harvest something. Peter's the one who came up with the catchphrase 24 fresh, that was then trademarked. And basically by that we mean we harvest it in the morning, we get it to the distribution, it rolls right on through a distribution center, is back out to and it's in the store the next morning. So 24 hours after harvest, it's being purchased by a consumer.
Dave, we have a situation here in D.C. where we have 25 subterranean acres, 25 acres that is thermally stable at 72 degrees. And what the city is trying to do is blow it up and build high-rises on them. And I want to put the largest aquaponic farm in the world down there. We could grow 19 million pounds of food every year there.
Well, I'll tell you, that might be a great opportunity. I'm going to say to grow lettuce. Lettuce is a cold crop. If you're underground, it's probably 55 degrees all the time. The lights will give you some heat there, so things will germinate. But I think it would be, you could, when you first told me about the acreage, I'm going, I can't imagine that much acreage in Washington, D.C., unless you're counting the Park Service around.
It was a sand filtration water plant. It was the original sand filtration water plant that fed all of D.C. before they came up with a chemical plant. And it's still there. It's still there, and it's stable and it's functional. And anyway, that's a subject for another discussion.
Yeah. But I think that is an investment opportunity. We've talked the first 3 sessions. We talked about 3 Ps and how we could, how you could be a local champion and getting together and trying to put that together. And there's a couple experts here on this panel tonight in 3 Ps. So doing that and actually making that dream happen of putting that in. Just throw a couple other things. Grow Farm, we talked briefly about that last week too. Min Farm, I mentioned about the growing pharmaceuticals. If you were on early and we were talking about nanobubbles, and I was interested in from the perspective of growing plants in a sterile lab environment and how that might help. But I do want to just kind of, you could say, toot our horn or whatever. Today we had some really great news from the lab at Mint Farm, and that we've been working through our processing program and a few other things, and found out that we've been running through some samples, and we have been able to officially, it's official now. We've been doing it for months, but we were actually able to refine it now. We're able to grow what's called VEGF, VEGF, which is a regenerative protein. It's used in cancer research, and it's a pretty expensive. What do you want to say? Protein. And so we had success. We just found that out a couple hours ago in the lab, so that's great. So there's another use for plants that can change our lives and all that. And then I think we're going to be talking about nanobubbles and how that can be not only manufacturing for it is in fish, but maybe some other areas. So.
Absolutely. Absolutely. That's wonderful news, guys. That's really wonderful. Congratulations.
Yeah. We're really excited about it because that's regenerative protein, and just give you a wild, here's the future of things out there. You've all heard of 3D printing and how they, you can print a car these days. You can print all sorts of things that you can manufacture. Well, one of my partners had a visit with the Mayo Clinic this week, and about 3D printing of body parts, and that is actually becoming reality. And of course, to make that, you need ink, right? And so it's not regular ink. You need regenerative proteins that can mimic human tissue. And so that's one of the things that we're. That's why this is such an exciting thing, is that being able to grow regenerative tissue and be able to then in the future here use that in 3D printers. This will be helping all sorts of people, from basically printing replacement bones, maybe a finger or the little bones in your ear that allow you to hear. Printing skin. There's all sorts of things that are out there. So the fantastic technology that's going to impact our lives in the future. So, enough of me talking. Let me hand it over to Jerry, and when you want a slide change, just say, next, and I will.
Jerry, before you get started, let me just jump in and piggyback on Dave. Dave, you invited us to speak. So, one of the things that what Dave is pointing out is that there are so many different ways that this connects. By forward moving distribution and aggregation of agricultural crops, by building facilities where the consumers are, but we're also learning that there are so many things more than just food and agriculture. If you put one of the farms next to an ethanol plant, or someone that puts out CO2 and needs to sequester that. Plants need CO2 to grow. So if we can feed the plants CO2, we increase the density. If nanobubbles help increase yields, we increase the density of growth per square foot. And that's the key to indoor agriculture, vertical agriculture, is density and electrical cost. And if you can buy the best farmland in Iowa or Minnesota for $10,000 an acre, and I buy 100 acres of land, that's $1 million. But if I buy $1 million warehouse to put a farm in, then I better be getting 100 acres worth of produce out of that building so that I can have enough yield to overcome the capital costs of that $1 million building, and to be comparable and competitive with outdoor farming. So the ability to create density by going vertical and using any other way, whether it's getting CO2 from an ethanol plant or nanobubbles to help boost that yield in a shorter growing time, just helps us accomplish the goal of being sustainable.
Absolutely.
So that's a really key kind of thing. But there's all these synergisms that, besides, we didn't even talk about the health and beauty, which uses essential oils and other things which you can grow in these systems. So there's industries besides which you can deliver organically grown natural substances that are better for the consumer.
Yep. Yeah. Sorry to interrupt there, but what Peter's talking about is what you saw there before about the urban garden in a container, and you think about health and beauty and other industries that are using, how many things are made with natural oils? Whether it's we're not growing coconut trees in there, but cocoa oil, basil oil. Basil oil is in a lot of things that you don't realize. But now what you're doing is you're streamlining production. You actually have something like this in the parking lot. And so now how does that change not only the economics, but the dynamics of supply chain management for a company? Now they're not beholden to the weather or price fluctuations because they're growing their own key type of raw material right in their own parking lot. So yeah, there's a tremendous amount of areas there. And I'll just would say one thing, and then I'll turn over to Jerry here. One last thing, and I'll just say this may be surprising you, but who were the first environmentalists? And my answer is they're accountants. Because if you ever talk to your accountant, what does he say? He says, well, how can we save that? How can we use less power? How can we reuse the scrap? How can we do that? And so that's exactly what an environmentalist is thinking about. How do you have to cut the waste or make it useful in other ways? And so if you've got a power plant that's creating CO2, how do you turn that into a benefit for you? And so that's why I kind of jokingly say that accountants were the first environmentalists. So anyway, Jerry, turn it over to you.
Yeah, every time someone says something, I think of 5 things that I want to say about it. That's exactly true. And the woman who's the head of Sabine O'Hara, who's head of University District of Columbia here in D.C., wrote a book called the Physics of Environmentalism. And in the book, she talks about negative sinks. Everything that you do has a negative side to it. The question is, how do you employ that sink as an input to something else so that it's a productive, as you just said, so that it's a productive byproduct. The facility we're looking at in Baltimore, for example, that I want to show Peter, is 143,000, and it's right next to a trash to steam plant. So not only would we have access to the CO2, but we would have access to 110-degree hot water, which they pump all over the city, which could really dramatically. So those are the kinds of things that you want to look at if you're starting this kind of a business. It's the business. I come up with a concept called food as a sustainable technology, and I think that we're looking at, as Ray Kurzweil said, we're looking at the singularity here. We're looking at a curve that's increasing in height and it's accelerating, and we're at a place where we could actually have a paradigm shift in food production. I don't want to go on about that, but that's the future. That's where we're going, and we're there on the edge. The 4 of us, the band of brothers that's talking about this, we're having those discussions that are right on the edge of making that happen. Okay, so one of the enabling technologies, I believe, are nanobubbles. By the way, nanobubbles it's an awkward term in Spanish. It's bubles, and in English it's bubbles. And bubbles are like baths, and so I'm thinking that we should not use the term bubbles, but use the term ponics, which is a relative term, and call it nanoponics. And nanotechnology is very exciting. Everybody wants to be involved in nanotechnology, and so you tie the 2 together because it's a legitimate thing, and you have now a marketing term that you can play with. So we talked about this before. What are nanobubbles and how do they work? And we went over it very quickly. And what I'd like to do is just go over some of the details again. Earlier we talked about about system applications, and here are a real spread of the kinds of things. Incidentally, all of these slides were produced by Wintersol, our partners in Bogota, and we're the U.S. distributor for them, so we have our logo. There are ecological benefits, and there are environmental benefits, and there are commercial benefits, and you can see them all there. And I submit that if you have access to the technology, then you can de facto become an environmental engineer if you hire an environmental engineer, and perform environmental engineering in addition to the improvement of the food process, and as Peter said, other processes as well. Next. Can we advance the slide? Okay. So
I did too. Did you want it back one?
Yeah, go back one. Yeah, I just wanted to show that. Yeah. So this is basically how the nano and Gustavo, if I say something that is incorrect or unclear, please feel free to correct me, because we want to provide accurate, transparent information here. Nanobubbles are created in a fairly simple machine that, and there are a number of them. I think there are about 10 or 12 people who manufacture nanobubble equipment. The difference is, as I said earlier, the difference is that this particular machine increases the magnetic properties of the nanobubble, which are important to get the efficacy of nanobubble technology. They'll stay longer in the water. They move better through the water column, and they adhere to heavy metals and actually decant heavy metals and float them to the surface, so they're easily skimmed off. It also eliminates oil, separates oil and water. It's an excellent oil and water separation model system. Next slide. Okay, so this is a bit of a more a close-up of how the actual system functions. And you have copies of these slides. Peter, if you want to take a look at these in detail and have questions, which you probably will have. And you'll have Gustavo's contact information, so you don't feel that you have to come through me. If you need to speak to Gustavo, you can go directly to him. So the smaller the nanobubbles come in different sizes, and there's a definition for a microbubble and a nanobubble. And while I don't understand the details of how the nanobubbles actually transfer their atoms to the water, I know that that's what happens, and that's why the water becomes so superoxygenated, or can become superoxygenated. Okay, and that is a description of what. So move on. Let's move on to the next slide.
Did that make it?
Yeah, we got it.
Okay.
So this is the whole thing is about area of contact between the nanobubbles and the water. And the more nanobubbles you have, the greater the area of contact. And the more effective the nanobubbles are in the water. Okay, and that's the machine. There are a number of ways of doing it. This is, we believe, the best way to do it. And as you can see on the right on the graphic on the bottom side, that's this Brownian motion that I talked about earlier, where nanobubbles are essentially have negative buoyancy. They go down to the bottom, and then they come back up, but over a protracted period of time, where you might have a regular bubble do that, let's say in 10, 15 minutes, take a nanobubble 10, 15 hours. There have been cases where the nanobubble generators have been shut off and nanobubbles were still persistent in the water, 5 days later. So there's a real stability issue here that is increased by the magnetic. Let's move on. Next slide. So again, this is a further illustration of how the actual unseeable tiny, tiny. That's one thing I think that people have a hard time putting their heads around, and that is how small, actually small, is a nanoparticle. A nanobubble is so small that it can pass through the mitochondria of a cell. It's so small that a reasonable size nanobubble is about the size of 2 gold atoms. Or one gold atom, actually, not 2 gold atoms, 1 gold atom. So you might have 1 or 2 nanobubbles that would be the size of gold atoms. Very, very. I mean, you can't see them when you look at nanobubbles in the water. It looks like a cloud. You can't see it. You're shaking your head. What did I say wrong?
No, no. The only thing is that you cannot see nanobubbles. When you have a cloud, when you have a cloud in the water, that's microbubbles. Okay. Nanobubbles are actually you cannot see. The only way to prove that you have nanobubbles in the water is by laser. Okay? That's the only way. Because if you see the water, you don't see anything. I mean, if you start watching a glass of water with nanobubble, you don't see anything. It's transparent. The water.
I can understand that.
So when you see a cloud of oxygen or a cloud of gas inside the water, that's not nanobubbles. You maybe have a small amount of nanobubbles inside the cloud, but you cannot see it.
Okay, it's
impossible to see.
We stand corrected. This is a good thing. Thank you. Next slide. Okay, so this is what this is a slide provided by Wintersong, and this is a slide that shows it's a physical representation of a RAS. The mechanical filters, the UV. This is a RAS. This is designed. This is not a system designed for aquaponics. It's designed to grow fish. So you have UV in there, which is a sterilizing technology. But you notice where if you look to the right-hand corner of the diagram, the right-hand corner where the tank is, and go down the tank, you'll see a red arrow which says here, it says high care. That's the nanobubble generator. It goes in before the tank. It goes into the tank. Okay? Now that's an RAS. Now let's move forward. Next slide. Okay, this is a schematic, a functional diagram that shows where the nanobubble generator is inserted, and it also shows where the air nanobubble generator is inserted. And I'm going to let Gustavo take you through that graphic. Gustavo, would you take us through the graphic, please?
Okay. Well, this is a simple sketch. I mean, we have the production tanks where we have the fish, and we have all the treatment plant to remove solids and to remove grease, and we have the biomedia where we actually transform the ammonia into nitrates, and then we have 2 separate ways for the water. We have the one that's going to the hydroponic component, and the other one is going to, again, into the production line for fish. So what we do in our systems is that we put the nanobubble machines before the production units. Even though it's vegetables or if it's fish, we have to put the nanobubbles directly before the production lines. Why is this? Because we are going to give the crops and the fish and the vegetables a very good quality water, a high quality water with nanobubbles. So the plants and the fish are going to be able to take the oxygen in case of the fish and the nitrogen and the oxygen in nanobubbles in case of the vegetables. So in this way, we don't affect the biomedia. We don't affect the the nitrogen process, the nitrification. We don't affect it because when nanobubbles they get into the biomedia again, they are very diluted. Why? Because it's been through the unit tanks with fish and vegetables, and it's going through the treatment plant. So we have agitation there. We have a MBBR. So almost all the accidents of the air of the oxygen, sorry, it's removed from the water, and then we can use the water with normal levels of oxygen before entering the units of production.
And one of the things that I noticed in looking at we have some videos that we can share with people. You know, this is really under the heading, although I'm sure in thinking retrospectively, this sounds like selling. But really what it is presentation. We're trying to show how nanobubbles can actually be the tool that makes aquaponics work. Let's go to the next slide. We only have a few minutes to get through this, and I don't want to end up with slides undone. And you can ask questions about any of these things, and we'll respond to them. So I've been meaning to break this into a features benefits list because there's features and benefits in here, but it really does put forward the advantages and the main impact that micro and nano bubbles produce. Gustavo, would you comment for a minute on the relationship between micro bubbles and nano bubbles?
Well, a micro bubble, it's a bubble that you can see. Actually, you can see when you make some agitation in the water with your hand, you produce micro bubbles, and you produce millibubbles. A micro bubble, if we compare the lifting of the micro bubbles from the bottom to the surface, when a nanobubble is set inside water, it takes around 55 minutes to reach the surface in a column of water of 1 meter. And microbubbles reach the surface in only a couple of seconds, maybe 12, 13 seconds. So the time of oxygenating the water for a microbubble it's very little. I mean, we have only 12, 20 seconds maybe, depending on the size of the microbubble, that is spreading the oxygen inside the water. A nanobubble, it almost disappears inside the water by letting the oxygen in its into the water.
Got it. Okay. So one of the things that I would bring your attention to is number 3, the pressurized buoyancy operation. Okay. The exfoliation and flotation of waste particles. The nanobubbles adhere to these particles, and if you don't get them in the drum filters and you don't get them in the mechanical filters, you can get them in a skim filter, because the nanobubbles will bring these to the surface. I noticed in looking at the water in the tanks that Gustavo's videos he sent me, normally when you're looking at tanks with aquaculture tanks, it's live water. It's like there's like a green cast. It's like the part of the biomass in there. It's green. But when you look at a tank that's being serviced by being injected with nanobubbles, the water's clean. I was really surprised. I mean, it looks like almost like aquarium water. Or is that right? I mean, it's clean water, which is kind of amazing.
Nanobubbles remove everything from the water, from organic matter to grease to oils, and some of the small particles that the filters are not able to remove. The nanobubbles take it away from the water.
Okay, next slide. And these slides are available if anyone wants to see them. Okay, so we propose that as an entity that we consider these as part of a integrated system. That's part of what we're proposing here. Next. So from an aquaculture point of view, what we're looking at are the kinds of fish that can be cultivated in a RAS. You look down at the bottom, you'll see tuna. Dr. Yoni Zohar at the University of Maryland, who's probably one of the foremost aquaculture scientists in the world, has closed the cycle on tuna, the life cycle. In other words, he doesn't have to go and get tuna from the wild fingerlings. He can grow brood fish that will grow, and they'll breed in captivity, and they'll breed in sufficient quality and sufficient quantity so that it makes sense to do it. He's doing it with barramundi. He's doing it with as you can see. And he's in Baltimore. So some real interesting potential there. Next slide. Okay, well, you know, these are just some of the bananas. We talked about most of these things. Let's just move on to the end. These are available. Next slide. So this is the final slide, I think, and I wanted to make this point because we have, as I said, formative data that shows this. But this is an actual a growth experiment. This is the difference in growing with nanobubbles and not growing in it with nanobubbles. And this is not just aquaponics. This is hydroponics. This is anything. So that's why we're excited about it. I mean, clearly. The question is, are we correct? Is this right? And that's what we want to do. We want to document this right between the eyes. You know, objectives. The problem is we don't have the funds to go to a Patel Memorial Institute or to a JPL and have them do it. I'm trying to convince the University of Maryland to do it, but they're looking for sponsored research. They want someone to pay for it. Okay, so I'm trying to convince them to go to the state and get the state to pay for it. But it's in everybody's best interest to know if this is the truth. We have data that says it is the truth, and we have data from all over South America that says that it's the truth, and we have the data. The question is, in America, it's going to be American data. Just like in Japan, they want it to be Japanese data, right? So that's the story in a nutshell of how nanobubble technology can make aquaponics universally a success, and how we can be instrumental in making that happen on a national basis. You know, in other countries, I received an RFP because I'm on.
Jerry's frozen up a little bit. Something happened with him there. We're actually we have a lot of questions, guys. So maybe while we're waiting for Jerry to become unfrozen, and he will, why don't we address some of these questions? So I'm going to go ahead and read through them, and whichever of the panel is best to answer them, you guys go ahead and do it. So the first one, and Richard is the one asking these. Richard is very interested in this. So, you know, did you guys address his first two questions, but is there a benchmark for the number of gallons of aquaponic tanks per machine? Has that been done yet? And that's a very good question. I know there'd be a lot of variables in that.
Right, we did actually. Gustavo said that he does have a questionnaire because we know that it's you know, biomass and temperature and species and barometric pressure and how
There's
deep
a lot of factors
things are. Yeah, there's a lot of variables. So and Gustavo was going to send that questionnaire, and then we would post that on the website. We'll give it to Mark to do that, and then Yes, we would. Yeah, we would do that. And I think Richard had reached out to us with an email earlier today about some other questions. So maybe we can answer those for him directly, and then we can also, for those others that are interested. And I see Richard also had another question about the. Well, maybe it was Richard who was talking about the grocery chain. Did you want to read that one?
Well, that's just a comment on his part, is saying that there's a grocery chain that buys 1.6 billion, that has 1.6 billion in revenues, but only sells 6 million in produce per year. And then another one where a New York City produce distributor sells $1 billion worth of produce per year, which makes sense. But here's a good question from him. What is the break-even point to go indoors? This is not so much nanobubbles. Versus energy efficient greenhouse. And so that, if you guys have an answer to that, that's fine. I don't think it's as simple as maybe Richard would like it to be. Probably the same sort of thing. I'll answer it. I've been growing indoors in both greenhouses and warehouses for the last 10 years, and in shipping containers and every kind of indoor environment you can imagine. And the answer to that question is going to be all the same variables that were mentioned for determining how many microbubble generator machines are needed. It's different for every kind of production system you have. ECs, everything. So you can't just answer that as simple. I don't know why Richard does make a comment. Power is likely to be a limiting factor. Why is that, guys? I don't see why power would be a limiting factor at all.
Well, I'll say, let me answer that and say that we do have a model. So we, basically like a questionnaire. You give me a bunch of the variables. It's going to matter. How much is your electrical costs? If you're in New York City and it's 25 cents a kilowatt hour, or in Colorado it's an 8 cents, that makes a big variable. Your cost of your building. But on the other hand, if you're growing something in New York City, you might be able to get more for it, or you might be able to distribute it with a bicycle than if you were growing it, in Colorado and getting it to a bunch of customers. So, yeah, it is a very complicated answer. I'll just say that we do have the answers. We do have the equations. We can figure that out based on, so we have a spreadsheet. It has a bunch of variables that we can input, and it will tell you where that break-even is going to be.
And Richard says utility availability. That's what I thought he was saying. Richard, gosh, most industrial buildings that are being refurbished for any kind of indoor agriculture use, and again, I have a lot of experience, like 30 years working with billions of square feet of buildings. They're way overpowered for any current use. Forget about what it is. They put so much power in these buildings. I'll give you an example. The Ford building in Lorain, Ohio, that is one that I was a part of the purchasing team for. It's where they used to make Ford Tauruses and Econoline vans. 9 million square feet of total space in the facility. They had, and don't quote me on this because it's been a long time, but I'm gonna guess a number. They had, I think they had like 500 megawatts of power coming into the building. They never, using all of that production that they did, they never used more than 150, meaning they had almost 4 times as much capacity as they ever used. That was a typical process. Power was so cheap back in the 40s and the 50s compared to the manufacturing profits or revenues that could be made. Almost all of these facilities are overpowered. And so power is very really ever an issue. Jerry's talking about the cost side, or Dave is. That's very important. But the ability to have the power there, that's not. I don't think that's going to be an issue for indoor agriculture.
Well,
Wayne, can I? Peter, go ahead, Peter. You're going to chime in about the.
Yeah, let me, because that's not true of all buildings. Because if you find just a simple warehouse building, they're not necessarily going to have sufficient power, as we've found out in St. Paul, where we've had to add power to that building. But really what it comes down to is what is the end sales price of the products you're selling, and when you back that off to include your margins, I mean, then you come to what can I literally spend as a cost of production. And of course in that calculation is going to, power, labor, lease of the building, etc. We found that power was number 3 on our list, but we know others that have had, seen a range of from 41 cents a plant for electrical costs to grow that plant to our level of 4 cents a plant, and that makes a big difference if you're limited to, say, 50 cents a plant in production cost capability. And so it really comes down to then the fact that when you bring a crop indoors, you now have a huge capital cost to overcome, which is both your greenhouse or your warehouse. And given that, you have to have enough density in that production facility to overcome that capital cost. And so that's a big factor. It's, for me anyway, it's one reason why greenhouses have had so much trouble, because they tend to not grow vertically. They bring an acre indoors and put it on a table. Wayne, you've got a lot of experience in that area, so you may very well know how to overcome some of that. But what we have found is that if you bring it into a warehouse building, you better have at least 100 acres worth of equivalent production out of that building. And right now, with a lot of the technology that's out there besides ours, they're limited to somewhere between 25 and 40 acres equivalent production in a 1 acre building. And that's not enough. And that's why you've seen some failures. So the density levels that you can get out of a facility to overcome the capital cost and the electrical cost per plant, which on our list was the number 3 cost expense, has to be in line. And if you can overcome those 2 things, then this becomes a hugely profitable and successful business.
Well, and I totally agree with that. And back to your comment, I was dealing, again, with buildings that were built initially for heavy manufacturing, not something that was built to be a light commercial application situation. But Dave, even in your Maplewood building, have you ever used the amount of power that you had in there for the manufacturing that you had?
Yeah, no, we have 3-phase power in it. We were doing, actually, it was a light assembly in packaging, previous businesses that I had in there that I sold about 12 years ago. And we had packaging equipment and shrink tunnels and things like that. So we needed the 3-phase. And now we have this, we have all the orbiting gardens and the vertical fields in there, and the building's full. And yet we still have plenty of power left over. But Peter's right. When we went into it was a really light building. It was more of a warehouse building, not an assembly building. And Wayne, what was very interesting about your story about in Ohio, I remember you were telling me about how much power was just being consumed by the resistance of electricity going through all the electric wires to outlets throughout the building.
$100,000 a month in phantom power loss in that facility. $100,000.
The internet went down on me. It just went down. Boom! I lost everything.
Yeah.
Well, we don't see you, but we hear you. But we don't see you.
You're back now. Let's go back to nanobubbles a little, and I don't see any other from the audience. I have some, and I'm just going to ask a couple, and mainly they're for Gustavo. And I'm going to be a cynic, so please don't take these to be that I'm being negative. I just think these are realistic questions. Again, and I'm a scientist. I understand the technology, but and I don't, by the way, agree with a lot of what Jerry says. I really do think that there's a lot of hype there. I mean that, and I don't. I just think that we have to be careful about that, and that it isn't miracles. And there is science here, and how it was described in the way that basically you can charge nanobubbles and cause them to go down rather than up before immediately. That's a huge, and that is science, and that's validated. But here's a question, Gustavo. Why isn't this technology catching on? Why can't you hardly, why are you even talking with us? Why aren't you just selling so many of these units that you just can't even keep up? What's the problem?
Well, first of all, yes, it's not a miracle. Okay, as you said, this is science. Japanese are been investigating and working with nanobubbles since 1970s. The main reason why these machines are not sold as hot bread, as we say here in South America, is that the market is very skeptical. I mean, they do not believe that nanobubbles are able to do all these things we're talking about. Even though not only us, but also the Koreans, the Japanese, there's an American company that is also working with microbubbles, not with nanobubbles, but with microbubbles, and they're having very interesting results. People simply they don't believe what nanobubbles can do, and but recently we have we've been reading a lot, and we've been making a lot of research, and in the world the nanobubble technology is like asking for some permission to enter to the industry. I mean, all people, very important companies are starting to invest in investigation for nanobubbles. As a matter of fact, all this nanobubble technology started in Japan with the Subaru and Nissan. They needed something to clean the water from the industry of painting and everything, and they found that nanobubbles were the solution, and they started using it in around the year 2000. And well, they rapidly understand that the nanobubbles were very good cleaner. They clean very well the water. They eliminate a lot of things from the water, not only metals but also oils, grease, phosphates. They're capable of diminishing the BOD and also the COD. And, well, I mean, as I was talking before, we are a part of a very huge possibility to start developing nanobubbles in a lot of fields, not only in aquaponics and in the agriculture, but we also have been able to make very nice findings in the cattle growing, because as if you give nanobubble water to only with air, not oxygen, just air, to the animals, you will reduce ammonia in the urine, and then you diminish others. You eliminate some CO2 from the deposition of the animals also. So I mean, we have the future in front of us. There's a lot of things that have not been discovered for nanobubbles. Here in Colombia, we have a doctor. It's called Ginas. He's working for around 5 years with nanobubbles as transport for delivering medication to the cells.
That's being done here at the University of Maryland as well. They're using a surfactant instead of water.
Yes, they're using nanobubbles to cure Alzheimer's. So this is brand new, and I believe that's the answer for your question.
But we're talking about science here. I mean, Wayne raised the issue of science, but the question that was asked was not a science question. It was why, if this is so good, why isn't everybody using it? And I think the question we need to answer is to test it and find out if it works.
Right. You're exactly right, Jerry. I am the scientist, and honestly, the science is very easy to validate, and I'm asking it from a completely different perspective. It is really the business case. Businesses have never been slow that are innovative to rush to solutions that work. And
I disagree, Wayne. I disagree. I think businesses are very slow. People do. I've worked in industry for 35 years, and you will be amazed. And you should know this. You probably do know this. That businesses do things because that's the way they've always done them. They're averse to change. They don't want to change their equipment because of their amortization schedules and taxes. They're moribund. Look what happened to Kodak. Kodak had the world by the nuts, and it just threw the whole business away.
But Jerry, I'm gonna really take argument with you on that.
Please,
that's a perfect example. That's a perfect example. You picked out one company, but let's just stay with that. Let's stay with moving from photos to digital technology.
Sure.
The industry moved very quickly. Kodak screwed up. They didn't follow.
Well, then let's use the same analogy, and let's apply it to another business I knew very well, and that's automotive manufacturing. We had the technology to go to CNC machines 20 years ago. We could have beaten the Japanese to the punch because we had the technology ahead of them, and we didn't. We didn't modernize our machines. We used our old lead screw lathes and stuff, and we're trying to hold tolerances, and we couldn't do it, and that's why American cars sucked. And the whole industry did that. I was at Millicron when it was going on. We could have this argument. You're probably going to be better at it than I am, but what we wanted.
I'm not going to be as emotional about it as you are. Whether I'm better at it or not, that's not going to be the point.
I apologize.
So to be honest, Jerry, that's
this is a way here. Basically, I'm a scientist too, and so I'm kind of a doubting Thomas. I like to see it with myself. Now, Jerry, you and I have talked about this before. You were looking for a place to test it. I was thinking about, Peter, I was thinking about our germination beds. We have two of them that are identical. They've got fish, they got plants growing, and we could have a nanobubble growing in one and doing the other, and we would be glad to, I don't know how big the nanobubble machine is, but we'd be glad to test it, be that verification.
And Dave, I've volunteered the probably third or fourth largest tilapia production facility in the United States to also test. So I don't think that getting entities comfortable with testing is going to be a problem at all. Somebody's got to pay for it, so that's a problem. And they're going to have to pay for the technology to come in. They're going to have to pay for the time and effort to do the appropriate testing. But and certainly, Jerry, I do agree with a lot of what you said. I mean, Henry Ford, it's pretty evident that Henry Ford wanted to use an electric motor in what became in the Model T, and he got convinced by Edison and others not to, and Rockefeller and the others for completely financial purposes, greedy purposes, not technical and scientific purposes. So there's a lot of reasons why certain technologies don't get adopted and other ones do. But in the wastewater treatment side, Gustavo, are any major water treatment facilities using a nanobubble technology? Are there any anecdotal specifics of, let's say, a 1 million gallon a day facility using a nanobubble technology?
Well, as I told you before, Nissan are using the technology. Subaru is also using it. Toyota. All the Japanese manufacturers, the car manufacturers, are using them. The Japanese also use the nanobubble to recover eutrophicated lakes. China used the nanobubbles to recover the rivers where they make all the water sports during the Olympics. There are several examples. Right now, the big companies, the car companies, are using this technology.
And is there published information about that? So Richard, who's on here, could he go easily find a study or a description of any of what you just described? Is that out there?
Yes, of course. There's everything is in the internet, and I can proportion a lot of information too. I mean, there's a lot of information in the net.
Well, that's awesome. That's really good.
The thing is that Japanese are complicated. I mean, Jerry, you work with them. You know how they are. Very difficult to reach a data with them. I mean, it's extremely difficult.
The problem is a cultural one. The Japanese are first of all, the language is the problem, but it's mostly the cultural problem. The real advantage that these guys had is that two of the brothers actually lived in Japan. The father was head of the Japanese coffee board there, and physically knew the inventor. And that's how these guys ended up with North and South America license. Trying to negotiate with the Japanese from the United States. I worked for Honda American Manufacturer for 2 years as head of technical training, and I've been to Japan and back and tried to work with them, and it can be done, but it's an issue. I mean, it's an issue that they just don't think the way we do, and they don't have the same marketing sense. All of the marketing that's being done by Japanese in America is being done by American agencies. There aren't Japanese advertising agencies.
I mean, even the Koreans have their own micro bubble machine, and they are trying to validate everything the Japanese did several years ago because they could not reach the information that the Japanese were able to develop. I mean, it's really difficult. We ourselves we have to validate all the information that was that they propose. They give us some information, and we have to validate all the data by our own in Colombia. So it's really difficult to work with them. I mean, they say, okay, there you go. You have the machine there, sell it, but they don't give you anything else.
Go ahead, Dave. Can't hear you.
I'm going to just say, we are past our time here, and we've kind of gotten a little off topic talking nationality differences here. So we could debate that all night long. So
so what are we offline now? Are we still online?
No, Jerry. Jerry, we're live. This is with guys, if you guys want to have a business meeting at a separate time, again, that's something that you could do. Thank you, all of our audience. And Richard, you've asked a bunch of questions. It's going to be up to the panel here if they want to be sending studies, or whether that's up to them. If they'd like to do that, that'd be great. And thank you guys for being so patient, Peter and Gustavo, and being with us is really special. Again, if in my opinion, if any new technology is going to catch on, it really does take an open-mindedness, and it takes the ability to have a dialogue, just like you guys were able to do here tonight, and to take criticism and to realize that it's not personal, it's just related to making good decisions, and then to be able to handle them. And you guys were great at that and handled things well. Appreciate that. Anything else that Jerry and Dave, you want to finish up? Does the audience, you have any other questions before we jump off here?
Yeah, I see Richard had asked another question about looking for the documentation. So we have his email. So if Jerry and Gustavo, well, Jerry has it. So if you want to pass that on to Richard, so he has that tomorrow, and then
I sent Richard a good deal of information. I sent him a PDF with information in it, and in terms of validated studies, the studies that Wintersol did, they did in-house, and they're showing you what they found.
No, I actually think, I think we're referring to something different, Jerry. Gustavo talked about Toyota and a number of other Japanese companies, and he said that there were some studies available. That's what we're referring to here, not to the Colombian work.
If you could send, if you could send those studies, and then you know, those who are listening, that if you're looking to do this and you need that technology partner, you've got some people here on this panel here tonight that are ready and willing to help you here get these things done. We've got a lot of different areas, from fish production to food production to medicine to recreational. We got a lot of different areas there that people could get involved, and with the synergy of solving a lot of different problems. And so next week is our 10th and final week on our webinar series of indoor controlled agriculture. We didn't get to tonight's discussion questions here, but we can follow into those next week. So I appreciate everybody being online tonight, and we'll see you again next week.
Well, I'd like to add something I'd say. Peter, when we get offline, would you give me a call? You have my number? I want to talk about next week briefly, okay?
All right, will do.
Okay, thanks, guys. Thanks, everybody.
Goodbye, everybody. Thank you.
Have a fun weekend.
Thank you, everybody. Bye-bye.
Bye-bye.